Hello my friend, welcome to this video. This video I'm going to show you how to convert the Simulink Matlab into the VHDL or Verilog. So we're going to make the simple mathematical algorithm in the Simulink. We simulate and then we convert into the VHDL or Verilog. And first we browse the library from the Simulink. We have a lot of toolbox here, but you can press this little button like the arrow, green arrow. You enter the HDL compatible mode, and everything in the HDL compatible mode you can use it and convert it into the VHDL or Verilog. We have the Vision HDL toolbox, DSP, and then communication, motor control, wireless, and so on. But the basic is the HDL coder. You have a lot of RAM operation, floating points operation, logic, lookup table, math operation that I like it so much, and so on. You can explore by your own self. But here I'm going to to show you how to make it like matrix multiplication maybe. Let's say sorry, a little bit slow here. Okay, for example, we have the matrix multiplication toolbox here, and it's supported by the HDL coder, so we can convert it into the VHDL or Verilog. And also maybe we can use gain. Oh yes, let's see. So maybe I'm going to show you matrix multiplication 3 by 3. We use constant here. So I'm going to show you like a basic things, then you can explore in the next tutorial or in your own projects. Now, for example, here I have the constant, but I'm going to use a random generator number, probably generate 3 by 3. And you need to aware about this. The output here is a double. It's a lot for the hardware implementation. Normally you need to convert it into the fixed point. This is fixed point, one indicated sign or unsigned. I usually use 32-bit, and then here the last is the fraction number. I use 21. It's depend on what you need. Apply, and then we have 3 by 3. Also we have another one, and we can do like a normal Simulink. Oops. Here we're going to make it 2, the gain, and let's see in the display. Okay, after we build this like a mathematical model or whatever model that you want to make, we need to configure the solver if we want to simulate in the HDL hardwares. And we change the type into fixed step, and then the solver into discrete, and make it auto. This. And then here you can just put it 1. It depends on what the number, like the cycle. It's not the cycle actually. They can create like automatic things, I thought. Sorry for the background noise, but it's no problem, I think. So here we got a result. We have 3 by 3 matrix matrix input, and then we multiply the random matrix 3 by 3, and then multiply by 2 with the gain. Then we got the result. I think this is the correct. You need to just trust the Simulink. No, I'm kidding. Yeah, but yeah. Here actually you can do the debug. For example, here with one of my favorite, you can see the signal dimension 3 by 3, and then unit, no, base data type, yes, base data type, oh yes. So the input is a fixed point 32 bits with the fraction 21, and of course if we multiply it's becomes 64. Why? You need to open your book again, and then we multiply again, and then it's double again. So if we want to preserve the output to 32-bit fixed point, we need to specify here in the output data type, we need to change into the similar number. It's similar type actually. And then here also I just want to keep the type of variable. So you need to be aware about this, because if your data cannot, like, you multiply two number and then actually you should have a double type, but if you reduce it like this, you will probably get the overflow. Then you need to aware with the your data and then so on. Okay, right now it's got it. The output is fixed point 32 bits, and then I'm going to show you another, the timing diagram. It's pretty nice, I think. Pretty nice. Let's see. So here we can see the periods. The period is 0.02. This is actually, it's not timing. It's depend on what the code that you want to use in the end of implementations, but it can be like benchmark in the beginning or about what the sampling time. So actually the sampling is 0.02, and then you have time 1, so you can predict the number of cycle of something here. Explore. Okay. To generate the VHDL, actually first you need to include the Simulink Vivado in the path into the Matlab that I show you here. You can zoom a little bit about this, and then here we have the support of HDL code. If you don't have this tab, then go to apps and then search the HDL coder. Okay, here normally I will make the subsystem like this to isolate the implementations, like here. I want to make it the name Methi. Yes, Methi algorithm. Methi. Yeah. Okay, if we have the subsystem model, we can actually convert it into the VHDL or Verilog. But firstly, we need to specify what kind of architecture that we want to have in these applications. For example, here, if you right click and then go to HDL Code and then HDL Block Properties, the matrix multiplications, you can open here the HDL properties, this matrix multiplication, and every Simulink blocks, they have the different HDL properties you can adjust to adjust your architecture, hardware architecture in the end of implementation. For example, here in the matrix multiplication, you have a dot product strategy fully parallel. You can change into the serial multi-parallel, multi-accumulate, and then you can specify the DSP style. It's on and off. Basically, every FPGA right now they have the DSP block that you can implement the matrix, the multiplication inside the DSP instead of using a lot of LUT. For example, I will just keep the fully parallel here, and then we can see the gain or what kind of HDL properties that they have. Here they have the DSP style. I'll make it on, and also this cons multiplier optimization. It's better to set it auto. You need to open the Matlab documentation to know exactly the detail what is this. And also the advantage of using the subsystem, you can set the subsystem HDL block properties. For example, we can specify the number of streaming factor, sharing factor, DSP style. I'm going to show you if we give a without the streaming first. Let's see. Here we need to specify this code for, and then basically it's better to directly jump to the workflow advisor. First of all, I'm going to show you the pure VHDL conversions, not IP core. I'm going to make another video to show you how to make the IP core and ready to use it in, for example, in Simulink IP core that you can integrate in Vivado directly. But here it's a generic ASIC FPGA. We have a lot of choice here, and then synthetic tools. Allow unsupported version if you have the bigger Zing ultra scale. Yes, this and runtimes. Yay, everything is okay. And here you can specify your target frequency. Normally I use a 100. So in the Simulink you don't have the concept of timing clock, but if you implement like in the VHDL, then you need to have aware. You need to aware with the clock. And here we have the several warnings. Yeah, I agree. That's modify all, and then run again. Voila, we got everything fixed. Run again, then maybe no. Generate everything. Okay. I forget something. It's better to open the configurations and then tick down every report here that you can see the report of your, actually there are a lot of configuration here. You need to explore by your own self. This is the basics things, and then run again and run again. We need to open the report because the report can give you the overview of your system after it's generated into the VHDL. So here the target language is VHDL. We have the clock summary, sampling time, and then here we have the input overview, and here the level resource report. We use a 27 multiplier, 18 adder, and then no register and so on, because we implement full parallel. We can see the generated here. It's the equivalence, but it's a bit low level. They convert the matrix multiplication block into this block, and this is the fully parallel. You utilize a lot of multiplier, which is 27, because we have like 3 by 3 times 3 by 3. But what's happened if we change the hardware configuration, like the number of streaming? Let's say give it 3. we will reduce the number of multiplier. Let's see, this is auto restore last configuration. No, you need to run off the stuff again. I will just skip it everything, but yeah. Do 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 do. I hope it's not a bit fast for you, but okay. Here, let's see. Here the number of multiplier, it's decreased, become 9. Header is 8. But here we have a number of register and another register for 1 bit, and then multiplexer. Here it is. So if we open the equivalent model, here if we run, here actually they use the serializer, and then they have the counter for counting, because we have the streaming tree, so they will count 0, 1, 2, or 1, 2, 3 actually. I don't remember, but they managed to divide the number of multiplier by the number of streaming. So if we increase the number of streaming, that's in factor of the total number of multiplier, that we will reduce the number of multiplier in the end. For example, if we put the 9 for the streaming, then we will have the multiplier 3. This is 3 streaming and then 9 for multiplier. And then in the end they managed, the Matlab managed to deserialize. So in the end result, the output is still similar with what we have in the simulations. So if we got this, and then we can see actually the code. This is the nice things. We have the given code. Isn't it cool?
No.
We have the Mathy algorithm. This is the input, and then this is the this is the output. No, this is the actually, yes, this is the actual, this is the input one, this is input 2, and then this is the output. This is actually the good things for you, the HDL designer. Then okay, actually we can see in the folder, we can explore the VHDL code and then the report and so on. But yeah, that's how we can convert this Simulink model into the VHDL. And also if you want to convert into the Verilog, then change it to Verilog. Okay, thank you very much for watching this video. If you have the question, please comment. If you feel this video is so useful for you, please subscribe and like this video. If you want me to create another video for another algorithm or another things in the embedded system, HDL or Matlab or FPGA or microcontroller, please tell me in the comment and I'm going to make it for you. Okay, thank you very much. See you in the next video. Bye.